Right. So let's start quickly. I hope that we'll be able to finish this chapter today. Binary. The binary will be tested fully, okay? And then we are left with a bit of theory. Theory also, there are certain sections that we are going to do. I'll let you know. So physical school and online school, online classes hereafter will be based on the theory, right? Okay, so yesterday we did binary, actually shifts. We came to shifts and we looked at an example of denary shift before looking at binary shift, right? We didn't do binary shift yesterday, but I just gave the introduction to shifts. Shift is basically moving a digit to the left or right, in order to multiply or divide a number. Like if you look at this as an example, if you don't understand anything, let me know, right? In denary, when we want to multiply a number by 10, we move each number. People are coming in. One place to its left and add 0 to the end. This will result in multiplying the original number by 10 and you get 130. So for example, like this, if you take 1, 3, or 13, right? These are ones, these are tens. And then here, if I put some zeros, this will be 100, this will be thousands, the positional values, right? And then we have a decimal point, right? To the right of the decimal point. I hope you can hear me clearly. All of you can hear me clearly?
Yes, sir.
Okay, great. So we have the decimal point, and towards the right of the decimal point, we have some zeros. And if you go to the right of the decimal point, this will be 1 over 10, and this will be 1 over 100. That you know, right? That we all know that about this. Now, if I shift these numbers to the left, one digit, okay, I'm going to shift this number one digit to the left, which means this 1 is going to move to this, and 3 will move to this location. So now 1 is here, 3 is here, and the empty space we are going to fill with a 0, right? And what is the result? We get 130. This one, 30, 13. This is 130. So what happened? The original value got multiplied by 10. So that is what is known as shift. So what we did was a left shift of one digit, which caused the original number to be multiplied by 10. Why is it multiplying by 10? Because we are talking about denary or base 10. So this is the same concept that we have to use for binary shift. Understand? Is that clear? All of you? Anyone wants me to explain again? Anyway, the video is recorded. I'll publish it and you go through, right? Any questions? You can disturb me anytime. No problem. Right. Now let's say I'm going to move this to the left 2 digits. 2 digits. Right? The original number. Now what will happen? Right? It was 0, 0, 1, 3, 13. 2 digits means this 1 will go 1, 2, 2 places. 3 will also go 2 places, 1 and 2. So now it will be here, right? And then 2 zeros for the empty spaces, right? What happened? The original number was 13 and now we have 1300. What happened was the original number got multiplied by 100. And look at this pattern, right? The base was 10, denary. We moved 2 digits to the left. So if you write it as a power value, 10 to the power 2, right? 10 to the power 2 is 100. This 2 will be the number of places that you shift. I moved 2 places. And if you write it as a power value and multiply or get the value result, you get 100. So 100 is the value that the original was multiplied by. So 2 places to the left, the original value got multiplied by 100 because 10 to the power 2 is 100. Is that clear?
Yes, sir, clear, sir.
Okay. And if you do it step by step, right? If you start moving digit by digit, right? One digit first, then another digit second. Then what happens is in every step, the previous value will get multiplied by 10 because you are moving it digit by digit. That means base is 10, your shift is 1, 10 to the power 1 is 10. So every time when you shift one place to the left, your previous value is going to be multiplied by 10. And if you do a shift straight away, like, shift of 3, then you can calculate it by like this, 10 to the power 3. 3 is the shift. So 10 to the power 3 is, what is it, 1000? 10 into 10 into 10, that's 1000, right? Yeah. So the original value will be multiplied by 1000 straight away because you are moving it 3 places to the left. Okay, so having that in mind, let's look at binary shift. Okay, now the thing is, there are 2 types of shifts that we are going to learn. This is a bit confusing and a bit hard, okay? 2 types of shifts. First type of shift is called logical shift. The other type is called arithmetic shift. Okay, so first we are going to look at logical shift. Okay, right. In both shifts, we have left shift and right shift. Left shift and right shift. Okay. So let's see how it works in binary. Okay. Logical shift. For unsigned numbers, logical shifts are performed in the same way as binary. For unsigned numbers, that's the point. Okay. So logical shifts are carried out on unsigned numbers. Now the question is, what are unsigned numbers? Unsigned numbers are, you remember sign and magnitude, right? Unsigned numbers are the numbers that do not have a reserved bit for the sign. That means when you have a number like this, you don't have a bit reserved for plus or minus. You don't have that. These are called unsigned numbers. If it is a signed number, the most significant bit will be used to represent whether it is positive or negative. That's what we learned under sign and magnitude. So unsigned numbers, they make use of all the 8 bits to represent the number, like this one. Right? All the 8 bits are used to represent the number. And what is this number they represent? You have 1, 16, 1, 4. So 16 plus 4 is 20. So this is 20. So the last bit, the most significant bit, is not reserved for the positive or negative. All the bits are used, and it's called unsigned. So remember, logical shifts are carried out on unsigned numbers. Is that clear? Is that clear? Logical shifts are carried out on unsigned numbers. What are unsigned numbers? These are the numbers where we use all the bits to represent the value. And there is no most significant bit reserved for the sign. What is the sign? Plus or minus. Okay, you get sign numbers in sign and magnitude. Okay, now this is 20, right? What have we done? If we multiply the unsigned binary number by 2 to the power 2, which is 4, what will happen? If you multiply 20 by 4, you are supposed to get 80. Okay, now let's see whether we get that when we shift the bits. Now, if it is a multiplication, where should we shift to? To the left or right?
So the right.
Uh,
Okay, so
uh, uh,
the left.
to the left, right? Left shift is a multiplication. Right shift is going to be a division. Okay, so the leftmost bits uh, drop off the end of replaced by zeros at the right. There should be the two shifts to the left. Two shifts to the left. Now, how do you know that there are two shifts? How do you know that there should be two shifts? Because you can see this 20 is going to be multiplied by 4. 4, if you write it as a power of the base, it's going to be 2 to the power 2. So just like the previous one, right? I told you, right? 10 to the power 2. So 2 is the base now, right? Power 2 is the shift. You write the shift as a power, right? This is the base. Base 2, power is 2, which means we are moving it 2 places. And this is going to be a left shift. Why? Because it's a multiplication. Okay, now what happens? 1 0 1 0 0. What has happened? This one, now watch closely, right? When you look at the video after the class, you do it on your own. Then only you will get this, right? Okay, this one moves 2 places to the left. 1, 2. So it's right here now. Okay, so once you get that one, it's easy to write the rest. You don't need to move these bits 2 places and make it more complicated. Just move the first bit to the right place, 2 places to the left, and after that you look at the pattern, right? So 1 0 1. So then just put 0 1. Okay, followed by 2 1, 2 zeros, 2 zeros. Just follow the pattern, right? Don't waste time on moving all the bits one by one, right? Just move the first bit 2 places, put it in the right place, and then follow the pattern. Right? 0 1 1 0 1, 2 zeros. And as a result of moving it to the left 2 places, you're going to have 2 empty spaces to the right. What are you going to do? You're going to fill them with zeros. Okay, so the new number is this. Okay, now let's see what this number is. We are supposed to get 80. You can see there's 164, there's 116, and rest are none. So if you add these two, 64 plus 16, that's going to be 80. Is that clear? Got it? Easy, right?
Yes.
Okay, let's look at another example. If you didn't understand, let me know. Then I will explain again. Okay, let's do these two questions, right? Okay, can you also do it? Take the exercise book. Do it with me. What are the results of the following shifts on unsigned integers? So first thing you should understand here is that they are unsigned, right? So the most significant bit is not reserved for the positive or negative sign. That means you can use all the bits for the number, right? And if you look at this one closely, it's 2 to the power 3. You're going to multiply, so it's a left shift. It's a left shift, 2 to the power 3, and the power value is going to be the shift. So can you tell me how many places we are going to shift this?
places.
What?
So 3 places.
3 places. Good. 3 places because it's 2 to the power 3. Okay. And can you tell me um, what is the value that we are going to multiply this with if we move it 3 places to the left? What is the value that we are going to multiply this with if we move this to the left 3 places? Venu, Monitha, Dihini, Senara, Salman, Chamatka. If I'm going to move the bits 3 places to the left, right? What is the value that we are going to multiply this with? In other words, moving the bits to the left 3 places will result in multiplying the number by what?
So by 128, right?
No. 128. No. What I'm asking is this number will be multiplied by what? This number will be multiplied by what? Dini, you told something.
Sir, it's 6.
No, it's not 6. What is 2 to the power 3?
So the number will be multiplied by 8.
Right. It's 2 to the power 3, and it's not 6. 2 to the power 3 is 8. Okay, so this will be multiplied by 8. This number will be multiplied by 8. And what is the number of shifts? It's this power value. This is the number of shifts, which is 3. So 3 places to the left, and the value is going to be multiplied by 8. 2 to the power 3 is 8. Simple. Okay, now let's do it. You also do it. Let's write the original value first. 0, 0, 1, 1, 1, 0, 1, 0. As I told you, just move the first bit. That's enough. We need another 0, no? Right, take this 1 and shift it 3 places to the left. 1, 2, 3. So the 1 goes there. And now don't try to move this 1 and this 1 and this here. Just follow the pattern, right? After the first one, we have 2 1s. So fill 2 1s. Right, after that we have a 0. And after that we have a 1 and a 0. Right, now we should have 3 empty spaces. If we moved 3 places, then we should have 3 empty spaces. What are you going to fill this with? We're going to fill this with zeros.
Zeros.
Okay, so remember this, right? We are filling this with zeros because this is different when you perform arithmetic shifts. So just keep this in mind, right? When you are moving to the left in logical shift, we fill the empty spaces with zeros. Okay, now we had to find out what this number is. Actually, we didn't find out what the original number was, right? Okay, first we'll find out what the original number is. Okay, this is 1, 2, 4, 8, 16, 32. What is this number? 32 plus 16 is 48. 56, 58. That's 58. Okay. What is this number? Let's write the other positional values, right? This is 32, 64, 128, 256. Okay, don't worry about 256 because this is here we are multiplying, so we can't really limit it to 8 bits. Right, so we have 256 128, 164, no 32, 116, right? High hatra the high, the heart high. You see other eye. Hatai, no man. Rahaloi, that's it. 464. Okay, now let's take 58 and multiply by 8. Got it. Understand? Easy, right?
Yes, sir.
Yeah, all of you do it. Do it by yourselves. If you move only the first bit and write the rest of the pattern, it will be easy. Otherwise, you will get mixed up. Okay, let me give you another one. I'll give you 1 minute to write this. And those who finish, you write, you do this one. We are not going to look at the division right now. That's next, okay? Okay, let's do this one. Okay, I'm going to give this in a different way. Okay, write the binary value after shifting the following 2 places to multiply. That's one. I'll give you 2 minutes quickly. Those who finish, raise your hand, right? Finish the. Shall you do it? Okay, check your answers, right? So first of all, what is this number? Can anyone tell me what this number is? This is 1, 2, 4, 8. 8 plus 2, 10 plus 1 is, what is the number? What is the number? Chamatkar, what is the number? Senara? Anyone?
Sir, is it 11?
It's 11, yes, good. It's 11, huh? 8 plus 2, 10 plus 1 is 11. Okay, now we are going to shift these two places, two places, right? So that's going to be the power, right? And it's a multiplication. So it's going to be multiplied by, this is going to be multiplied by 2 to the power 2. So this 2 power 2 is the number of places or the shifts. So 2 to the power 2 is, what is 2 to the power 2?
4.
4. That means the original value is going to be multiplied by 4. That means 11 into 4 is going to be 44. So our expected answer is 44. Right? So you can do that, do a bit of analysis first before you perform the shift, right? Okay, now let's do the shift. I'm going to write like this, put some zeros here. 1, 0, 1, 1. Okay, this one will be shifted 2 places. That's 1 and 2. So the 1 is going to be right here. Again, you don't need to move the other bits one by one. Just fill the pattern. 1 followed by a 0, followed by 2 ones. So you move 2 places, so 2 empty spaces are there, and you're going to fill these with zeros. So this is the resulting number. Okay, now let's see whether we have got 44. This is 1, 2, 4, 8, 16, and did I get it wrong? One, 2, 4, 8, 16. Did you get it wrong? One, 2, 4, 8, 10, 11. Two places to the left. 2 to the power 2 is 4, right? 44. Yeah. We should have 32, no? 32 plus 8 is 40. 40 plus 4 is 44. Yeah, correct. 132, 18, 14. 32 plus 8 is 40 plus 4 is 44. Got it? Understood? Is that clear, everyone? Can I see a thumbs up if you got it? Ah, great. Venu, Salman, Dihini, Chamatka? Venu, what about you? Okay, great. Right, so I hope you understood the logical shift, logical binary shift, right? And remember, logical binary shift is performed on unsigned numbers. A logical shift on, yeah, okay. Let's look at, okay, they haven't given the division. I move to arithmetic shift now. Okay, let's look at the division, right? Right, now division can be a little tricky because you are moving the bits to the right. Okay, first we'll look at the denary number, right? To understand this. Okay, let's say I have 100. No, let's say I have 50 or something. No, 20. Okay. What we are going to do is we are going to move the digits to the right. Okay. And it's going to be a division. If when we moved digits to the left one by one, what happened was it got multiplied by 10. Every time when I moved one place to the left, it got multiplied by 10. Then the exact opposite thing should happen when I move it to the right, right? When I move one place to the right, it should get divided by 10. Another place to the right, it should get divided by 10. Okay. And if I move the original number straight away to certain number of bits, certain number of digits to the right, it should be divided by the power value of that shift. That means if I do a right shift of 2 places, right, my original number should be divided by what? Should be divided by 10 to the power 2. Okay, or multiplied by 1 over 10 to the power 2. Okay, it should be the opposite, exact opposite. Right, it should be divided by 10 to the power 2. In other words, it should be divided by 100. Okay, so let's see whether that happens, right? First, we are going to move this to the right one place, okay? One place to the right, which is going to be a division. Right, what will happen? This 0 will come right here. The decimal point is here. The 0 will come over here, right? That's this 0. The decimal point will stay there, and the 2 will be moved to this place. 2 will be moved to this place. So 2 comes here. Okay, now the resulting value is 2. Earlier it was 20, now it's 2. What happened? 20 got divided by 10. I just moved it one place to the right. So the original number or the previous value got divided by 10. Is that clear? Is that clear? All of you? Okay. Yes. Let's take another example, right? Okay, let's take let's say 500. Okay, I'm going to move this to the right 2 places. Right, our number is 500. We are going to move it to the right 2 places to the right. And what is going to happen? The original number is going to be divided by, is going to be divided by 10 to the power 2. Why 10? Because it's denary. Why 2? Because it's 2 shifts. And why is a division? Because it's a right shift. Okay, so 10 to the power 2 means it's 100. So this number has to be divided by 100. So the answer should be 5. So let's see, right? So 2 places, this 0 will move 1 place, 2 places. And it's going to be right here, right? So don't get mixed up with these zeros, right? So the decimal point is still there. Okay, now 0 is there, and there should be another 0. It comes here, and then 5 should be there. So 5 comes right here. Okay, now you see this was 500, and this was 5. So 500 got divided by 100, and the answer is 5. Is that clear? If we moved it 3 places to the right, then 0 will come all the way here. These two, and followed by this 0, and followed by this 5, right? And the decimal point will be here, and these will be zeros. Now what has happened is the original number has got divided by 1000, and as a result we have 0.5. Okay, so we get fractions. When you go beyond the decimal point, we get fractions. Okay, understood? Is that clear? Speak, will you?
Yes, sir.
Okay, right, let's do this one now, right? Binary, on binary. 1 0 0 1 1 1 0 1. Let's see whether we have 8 bits. 1 2 3 4 5 6 7 8. Fine. So first do a bit of analysis. It's going to be a division, so it's going to be a right shift, and it's 2 to the power 4. So the original number is going to be divided by 2 to the power 4, which means it's going to be divided by 16. And how many shifts we have to do? The power value is 4. So it's going to be 4 places to the right. Okay, so do a bit of analysis like that before you start, right? And then here we need to have the point, right? Fraction, and then put some zeros. Because this 1 is going to be moved, right? To the right from the point. Okay, so 4 places to the right, right? This will go from here, 1 place, 2, 3, 4. So that one is going to be right here. Okay, now don't try to move all the other bits one by one. Just fill the pattern, right? So 1 0, you go from right to left. 1 0, 1 0. Then 3 ones. 1 1 point 1. Then 2 zeros. 0 0. Then another one. Okay, now you have moved 4 places. Then there should be 4 empty places to the left. Okay, what are you going to do for them? You are going to fill them with zeros. Okay, understood? Right, let's see what this value is, right? Let's see what the original value is first. Okay, this is 1 2 4 8 16 32 64 128. Right, can you check what this number is? 128 16 8 4 and 1, right? You also do it and tell me. My maths is bad. Hatarai pahai, dhatunai, dhatunai, siatai. Hatarai dhaturai, misidegai, siatai. Hatarai pahai. 157, is it? Is it 157? This number? Check and let me know. Is it correct?
Yes, sir.
Yeah, okay, great. Then this one. We'll check this one. Here we have 8. Here we have 1. Right? And don't forget that there's a decimal place here. Not decimal, fractional part. And this will be, right? Now the question is, what is this going to be? Okay, you know, these are 1s, these are 2s, 4s, 8s. Right? Then what about this one? Can anyone tell me what is this going to be? In denary, of course, this was 1 over 10. This was 1 over 100. So then what about this one? In binary, this is going to be 1 over. What is it? This is 2 to the power minus 1. That is 1 over. This is simple maths now. I did O levels in 1996. And I still remember this. At least a little bit. What is this? 2 to the power minus 1. 1 over. What is it? 1 over 2. Okay. And this is going to be 1 over 4. Okay. That is 2 to the power minus 2. 2 to the power minus 1. Okay. And this is going to be 1 over 8. And this is going to be 1 over 16. Okay. Now there's a bit of calculation, right? In the exam, since you are not going to be using, you are not allowed to be allowed to use calculators. I don't think you need to get the final answer, right? Try up to the maximum, right? Don't waste time on getting the final answer, right? So here we have 8 and 1. That's going to be 8 plus 1, which is 9. Then dot. We have 1/2, right? That's going to be 0.5. We are going to have 1/4. That is going to be 0.25. We don't have 1/8. We have 1/16. Now, what is 1/16? That is, I think, 0. Okay, let's see. One over 16. 0.625. 0.0625. 0.0625. Okay, now add them. What do you get? 0.0625, 0.25, and 0.5. 5, 2, 0.8125. And here we have 9. So that's going to be what? 9.8125. 9.8215. Now, what is our original number? 157, right? 157, and it's going to be divided by 2 to the power 4, which is 16. There you go, 9.8125. 9.8125. Did you understand? Is that clear? Is that clear? All of you understood? Great. Okay, what about others? Can I see a thumbs up? Okay, so I think in the exam, I think you can remember these fractions, right? 0 0.5, 0 0.25, 0. If it is 1/8, it will be 0.125, is it? If you can remember, try to remember. Otherwise, just the fractions is enough. 1/8, see, 125, right? 0 0.5, 0 0.25, 0 0.125, 0.0625. Just try to remember. Otherwise, just put the fractions and show your working. That's enough. Okay. Right. So I'm not going to do the arithmetic shifts today. It'll be too much for you, right? I will meet you tomorrow also. Tomorrow we will be doing arithmetic shifts, and we are finishing the chapter. Let me give you a homework, right? This arithmetic shift. But you can do the homework and share it in the group. If you do that, I will check them individually. Right? You don't need to send me personally even. You just share it in the group, right? So this is homework. I'll give you 2 questions. 1 0 1 1 1 1 0 1 0 1 0 1 1 0 1. Perform okay, multiplication of 2 to the power 2. This 1 1 1 1 1. Perform a division of 2 to the power yeah, 2 to the power 2. I'll make it simple. Okay, so this is for homework, right? Okay, any questions? Any doubts? Any questions? No? No questions? Okay, then we'll stop there, right? Okay, see you then. Have a nice day.
Thank you, sir. Thank you, sir. Bye, sir.
Bye. Okay, see you.
Thank you, sir.